Hello everybody, and thanks for joining. Welcome to our load testing webinar featuring JMeter. Let me start by introducing myself. So, I'm Rui Mendes from the Expert Architecture team. I'll be your host for this webinar. Moving on to the agenda, we'll start by establishing the ultimate goal of this webinar. After that, we'll cover some of the load testing principles as well as talk about our load testing tool, JMeter. We'll go through the test plans that we have created for your benefit, as well as look at different ways that you can use to analyze the results of running a load test. And finally, we'll top off with a live demo as well as some Q&A. So first, to align expectations, the purpose of this webinar is to show you a step-by-step guide on how we can quickly set up a load test on top of an OutSystems application using JMeter, as well as a set of template scripts that we created and that cover the most common test scenarios. We are hoping that by providing this accelerator, we can enable delivery teams to perform load testing activities during their project development cycles, instead of pushing these activities until the end of the project, where it is frequently discarded due to budget or timeline constraints. So as you all know, there are multiple ways to test an application. Load testing is just another piece of this puzzle. Each way has its different purpose and different granularity. Regarding load testing, what are the benefits that it brings to the table? So fundamentally, there are several outcomes that we can retrieve by running load tests. So things like measure an application response time under normal conditions, or evaluate how performance degrades when facing incrementally heavier load conditions until reaching a tipping point or a peak, or even identify performance bottlenecks that happen due to concurrent usage. But I think that fundamentally the question that load testing helps answer is the following. Will my application meet the expected performance goals under specific usage conditions? This is the main benefit of load testing. When you are performing load testing, especially on top of OutSystems applications, there are a few guidelines that you should consider in order to obtain meaningful results from your test runs. So you should start always by having feed data generated and available in your system that should be as close as possible to production, which will help you identify possible database bottlenecks. You should also set up ramp-up periods and pauses in order to generate incremental load on the system and emulate the user's think time. In case you might be wondering what think time means, is exactly what it seems. So it's the time that the user normally spends thinking before acting. And we should do this in order to make the test as realistic as possible. You should also have in mind and into account the need to use distinct user accounts so that you avoid a contention issue over session data retrieval. This is because of the architecture of the OutSystems platform, as it stores the session data on the database. Take a close look to your infrastructure and be aware of queued requests so that you can pinpoint where your infrastructure limits are. And finally, make sure that you make your tests idempotent in order to compare the results. This means that you should design tests in a way that are as isolated and self-contained as possible in order to ensure that the tests will always run under the same conditions. This will allow you to compare and extract the benefits after you improve your application or you optimize your application. You are able to measure the actual benefits that the optimization brought. And why choose JMeter instead of other applications? Well, for starters, it's free and open source, which allows you to use it to its full potential without having to worry about purchasing a license. It's extremely powerful in the sense that it allows you to model all sorts of user interaction patterns, as well as set up a large-scale load testing using a distributed architecture. And it's highly extensible due to an active community that constantly brings new plugins that you can easily incorporate into the core engine of JMeter. Well, on the downside, you have some disadvantages like a steep learning curve or an outdated look and feel that probably brings you back to the beginning of this century. But one of the goals of this webinar is precisely to mitigate the first disadvantage. So during the preparation of this webinar, we created a set of template scripts that you can easily adapt to fit your needs, and we will show it how you can do that during the demo, mostly through configuration of parameters. These templates cover a few simple test case scenarios, like logging in and logging out on an OutSystems application, navigating to a screen in order to trigger the screen preparation, submitting a request to a post action, and doing the same using an AJAX submit, and also invoking either a REST and a SOAP service call. But you can use these templates to, as I said, configure and adapt to your specific applications, but you can also use them as building blocks to build even more complex test cases using JMeter. Well, this is just an overview of the kind of elements that you will see in a test plan running in JMeter. So there are all sorts of elements that perform different activities, like thread groups, configurations, assertions, but we'll drill down on these elements during the demo with more detail. And after you perform your load tests and your test runs, you want to analyze the results. There are several ways to do it. So for starters, you can use JMeter directly using an element called listener. JMeter listeners allow you to have access to the information collected by JMeter during the execution of the test and display and process that information using all sorts of representations like charts or tables, performs aggregates. We'll have a look at that as well. Besides JMeters, focusing on the infrastructure, you can use performance counters, and focusing on the application layer, you can use service center logs that are automatically collected by the platform. On top of this, there are also some tools available in the Forge, like Performance CSI or Infrastructure Monitor, that you can use to perform additional aggregations and correlations on top of these last two sources, the performance counters and the service center logs. So I urge you to take a look at those as well. And finally, some considerations when building the test plans on JMeter. The first one, perhaps the most relevant one, the fact that JavaScript code isn't executed by JMeter. And this explains also why we cannot use Performance Monitor as another tool to analyze the output of a load test. Due to the fact that JMeter doesn't execute JavaScript, this means that the client-side performance metrics are not sent to Lifetime Performance Monitor because they are sent using JavaScript, meaning that all requests made through JMeter will not be visible in the Performance Monitor. Additionally, you should take in mind the following considerations as well. So first, you should adjust the number of concurrent threads to the hardware that's running JMeter. This is to prevent a breakdown of the hardware running the test due to an excessive number of threads. However, and as I mentioned before, if you are willing and want to perform full-blown high-scale load tests, you should use JMeter using a non-graphical interface to the command line, and you can use a distributed architecture to run the load test on several machines at the same time. You should also take consideration into the fact that you should isolate all custom data used on your test plan using request defaults, user variables, or data sets, namely in CSV. This will make sure that your test is as reusable as possible and you can use it to test multiple applications or multiple use cases inside of the same application. On top of this, you can also use parameters to instantiate variables through the command line. Finally, you should only use this specific kind of listeners called view results when you are fine-tuning your test scripts. This is because these results store all request data and response data that goes through JMeter and will have a toll in the performance of the machine running JMeter. So let's get down to business, shall we? So in order to do our demonstration of how you can quickly set up a load test on an OutSystems application, we will use the Case Manager application, which is also available in the Forge. And let us not forget that OutSystems applications are web applications. Therefore, they use the HTTP protocol on top of a client-server architecture, meaning that we'll be issuing HTTP requests and receiving HTTP responses through JMeter. We'll build two test scenarios. The first one, very simple. So it's just logging into the application and requesting the landing page. We will use for that a list of manager users, because the landing page of the manager is the dashboard. So the test will help us understand if there is any performance hazard in requesting the dashboard, which is a page that contains a lot of information. After that, we'll move on to another scenario, which is submitting the form through an AJAX submit. So after logging in as an agent, we will request a form to submit a new case, and we'll submit the form data using AJAX. So these are the two scenarios that we'll build. So let's start by bringing JMeter here to the table. Okay. So as I mentioned, outdated look and feel. So, and what we'll do is that we'll start by running the first scenario. Let me just pull back here to the first one. And for that, we will bring our template for the landing page. And for those of you which are not familiar with JMeter and now we can set up a test plan, let us do first an initial walkthrough of the contents of this test plan. So as I said before, there are all kinds of elements that you can use when building a test plan to perform all sorts of activities. So here on our template script for fetching the landing page, we start by defining a thread group, which allows you to control the number of threads that JMeter will use to run the load test. Not only that, but you can also determine what is the ramp-up period of the thread group, so which means how much time it will take until all threads are up and running. Each thread will run the activities inside the thread group in an isolated way, and we can use a thread to map to a concurrent user when performing a load test on top of an application. So after the thread group, there are a set of configuration elements here. So first of all, there is a list of user-defined variables, which you can see the variable on the left side, and here is the description. And this is what allows us to quickly configure the test and adapt the test to a specific situation. We'll start by filling these parameters after the explanation. So we'll get back to this. Then we have a CSV dataset, which basically allows us to fetch the content of the CSV file. On this particular file, I have a list of user credentials. So each line will be a login. And let me show you, well, the name of the file is again specified through a variable. This is the way that you can use to, inside the test plan, access the value of a specific variable. After that, you have an element called HTTP request defaults. This is the way that you have to set defaults for all HTTP requests issued by JMeter. So attributes like the server name, where the load test will run, or the protocol, or if you have a port number, you can specify using this element. And what we are doing here is using, again, variables to fill some of these defaults. Finally, to finish this configuration part, we have the HTTP cookie manager, which allows us to store and reuse cookies during all requests within the same session. So it's fundamental that you use this element whenever performing load testing over an OutSystems application. After that, you will see other kinds of elements. These are called samplers. In this particular, all of them, except the last one, are HTTP requests. So a sampler is a way that you have to issue a request to a server and wait for a response. Besides HTTP, you can issue different kinds of requests, like FTP, for instance, but for the specific test scenarios that we are building, and when testing the OutSystems application, we'll restrict to HTTP requests. Again, just a quick side note. By specifying here in my HTTP request defaults what is the protocol and what is the server, all of these requests will be targeted to that same server and using the same protocol. In this case, we will specify HTTPS. So inside the sampler, we have even more elements. We'll start with an assertion. An assertion is an action that you can use to check the response and basically to validate if the request we made was successful. So what we are doing here specifically is to check if a specific string is available in the response, namely this string, login to your account. And after that, there are elements which we call extractors that allow us to fetch content from the response for this specific request. In this specific case, we are using regular expressions to extract this type of content, and we are extracting different kind of elements. So the first two, we are using the regular expression to extract the view state of our request, as well as the view state generator ID. This is internal OutSystems variables, and the purpose of this script is precisely to do this heavy lifting task of ensuring that you already are fetching the necessary information from your requests whenever performing the load test. After that, we are fetching both the inputs where the user will specify the username and the password. Remember, this request will be a GET request to the login page, and in the response, you will have the two inputs, one for the user to write the username and other to write the password. And also a button, which is the login button that will trigger the post action. So this is all in the first request, where we are fetching the login screen. After that, we do a post, and we are simulating here an HTTP post, which maps to the user inputting his credentials and posting that information to the server. So what we do initially is to assert if the login action was successful, and we'll specify that through a variable. We shall see how. And we are also fetching, again, the view state and the view state generator, as well as the link to perform the logout. In this case, we are fetching the name of the input, the link input that performs the logout. So we will see that after the login, we will receive a redirect to the landing page, and the result of this login page is that we in fact request the landing page to be downloaded and to be displayed to the user. After that, we perform the logout, and for that, it's again a matter of issuing a post action and sending, in this particular case, the name of the link with the logout to trigger the logout action on the server side. Finally, we will assert if the logout action was successful by checking if the reply to the logout action includes this specific string, login to your user account. Finally, to complete the test plan, we add a debug sampler, which is just a sampler that you can use to store the values of your variables during the execution of the test. And we have a view results tree, which is a listener that, as I said before, will store all the requests and the response data performed by JMeter. So you should use this only for fine-tuning purposes. So what we are going to do now is configure the script, launch an execution for a single user, and then we can look at these elements to see if everything is all right. If so, we can start adding loads and more threads to the execution of this test. So let's start initially by setting up the variables. So I will fill this to adapt to our specific test, which is this one that we are seeing here in the back. So we will request the login page, and then we will be redirected to the dashboard because we are logging in with managers. And after that, we will post a logout request to the server. So let's start by filling in the data. So I'll be using here my personal environment. Let's hope it's not being maintained at this time. So I'll set up the protocol here. The name of the file, the CSV file containing my user's credentials, which will be users_managers.CSV, and this will be in the same folder as the test plan that we are configuring. And I can show you also content of this file. So in line with the best practices that we enumerated before, we have 10 different accounts for managers that we will use to perform the test. So after specifying the user's file, we'll specify the login page. This one. And now we specify the assertion to validate if the login was successful. And for that, we are using this text, which, as you can see here, in the picture, is this text, and we'll make sure that the login was successful if the response contains this text. And finally, we need also to specify here the relative URL of the landing page, because this is needed when you are posting the logout request in the last step of the test plan. So with all things considered, let's see, we are using a single user just for running the test and see if everything is all right. Let's take a look here at my listener, and as you can see, all of the requests issued by JMeter are being logged here. You can take a look at the result of the request, but for fine-tuning and script creations, you should take a look here at the requests and the response data that you received from the server. So, and as I mentioned, this is the request for the login screen. As you can see, this is being returned, and we are asserting again here if this message is in the received response. So if you look here, oh, sorry, just check it again. So yeah, log into your account. Yeah, so we can see that that test that we are checking in the response is there, so we can assert that the login action or the login screen request was successful. After we have the login action, which is a post to the server, and the server replies with a redirect, which translates in a GET request to the landing page, which is the dashboard. And as we saw it, in order to assert that the login action was successful, we are looking for this particular text in the reply, which is there. Finally, this is the logout that ends up showing the login page again. So, by using JMeter, we were able to successfully simulate a user flow that included logging into to an OutSystems application, being redirected to the landing page and asserting that the landing page is the one that we expected, and logging out, effectively terminating the session for this specific user. But this isn't very helpful with only one user, so let's pick up or increase the power here and increase the number of threads. And for instance, let's say 10 users, each one with a different user account, and let's say that each user and the whole thread group will have a ramp-up period of 5 seconds, meaning that it will take 5 seconds to launch all the threads. So let's also get rid of this debug sampler, which I actually didn't show you, but I can still show you. So this is a way that you can use to see the values of the variables. For instance, this is the server variable, the protocol, but also variables that we extract from CSV files, like the username, for instance, which is here, and also variables that you populate through the regular expressions extractors, like the login button name or the username input name. All of these are needed to execute the flow. So let's clean this. Let's remove these elements because we have fine-tuned the script, and let's add other listeners to show different ways that you can look at the results collected by JMeter. So let's use, for instance, an aggregate graph, which will perform several aggregations over the collected data, as well as display you a graph of the average response time for each request. So when you launch the thread, you will see that for each request, 10 samples are being executed because we have configured 10 threads, and for each of the threads, for each of the requests, you see the average time it took. You see other statistical information like the median, the 90% percentile, which gives you the information that at least 90% of the requests are under this value. You can also see if there are any errors when issuing the request, and you can have a look here at the graph and have a view over the averages for each request type that was performed in the load test. So quite some good times, everything under 2 seconds. So this is the first test scenario that we built, but we can add on and continue to build on this and add additional functionality. That's what we'll do for the second scenario. Let me just first, before going into that, show you that in fact all of these requests are being logged in Service Center. So let me just briefly pull Service Center window here with the screen log. Just filter this, and as you can see, all of these requests are effectively reaching the OutSystems platform, are being correctly handled by it. You can see that we have different users' IDs, and you can perform by looking at the server-side metrics. You can also export to Excel or use the analytics to perform aggregations and analysis on these results through Service Center as well. So after that, let's carry on to the second test scenario, where we are logging in as an agent, and we are requesting the form so that I can submit a new case in my application, and after that, submitting the form data using Ajax. So this is a test scenario that will allow me to see if the system responds well when there are concurrent requests for submitting cases on multiple agents at the same time. So in order to quickly build this test. So let's first clear this one. And let's go to different templates. So these are the lists of templates that we mentioned initially. So for that, we'll bring the Ajax submit with the form data. And to avoid here the copy pasting, I've already pre-filled the variables for this testing, but let's quickly go through them. So as in the previous one, we specify here the server, the protocol, the user's file, which in this case is a different file because it will contain credentials of users that are agents, not managers. There is also a different element here. We have the form data CSV. So this means that you can also submit cases with different information during your load tests. And let me just bring here again my notepad. You will see that I have at least 3 different data sets for creating cases. This could be helpful in situations where, due to the business logic, we are not able to create the same case with the same information. So JMeter allows you to use these data sets to vary the data that each rep will use during the execution of the load test. So this will be the form data. Like the other tests, we start by specifying the login page, the login assertion, which in this case is different because for an agent, the landing page will not be the dashboard, but will be the list of new cases. So we simply change that through a user variable. We specify what is the target page that will navigate to, and that will have the form to submit the case data, which is this one. The assertion to confirm that the page was correctly loaded. And after submitting the data, this is how we assert that the data was correctly submitted. So what we are doing here is, in fact, after the submission, checking if this element is in the response. After that, we have a set of variables to use in the extractors to be able to locate in the response what is exactly the HTML ID of each of the fields within the form, and we will use that extractor to post that information to the server when we are submitting the form contents. And finally, we specify what's the name of the trigger element that will post the content to the server. And all of these names are taken from the names that you specify in the eSpace. So when you have an input and you name it contact name, you can use that here in the load test script to, inside a regular expression extractor, retrieve the HTML on the response that corresponds to that specific input. Let me show you how exactly. So this is similar to the, and up until the login action you have seen in the previous test template. After that, you will navigate to the form data screen, which is the target page that we specify in the user variables. And when we receive the response to this request, we are in fact using the user variables inside our regular expressions so that we can extract the HTML name, the complete HTML name of the fields within the HTML form. And we do this so that in the post, which is the next request, we can post that information to the server. And as you know, in the HTTP post, the form data is a key value pair where you have the name of the HTML input and the value being posted to the server. So all of this is being made through configuration, meaning that you could easily reuse this script to test any similar form in your applications. Just to give you a final note before running the test, we are also in the Ajax submit action, submitting this element, the Ajax, which is the one that triggers the execution of an Ajax action in the OutSystems server. And what we are supplying here, if you drill down in the script, is exactly the ID of the trigger element that is triggering this Ajax action. Let's say if we remove this line from our test script, what we'll do is that the platform would simply execute a normal submit action instead of an Ajax submit. You can do it both ways. After asserting that the submit action was successful, again through a configuration parameter, we'll just do the logout and finish the test. So let's start here by doing an initial run with just one thread to see if we are able to execute the test completely. So, and then we'll drill down in the results. So yeah, the test was successful, meaning that we were able to issue all of these requests in the test plan to our application, and all the assertions that are being made within each request are valid, meaning that we were able to confirm that the response was the one that we were expecting. So let me just quickly drill down here. So this is when we do a GET request to the screen to submit the case. This is the response data, and this is where we will use the extractors to retrieve the HTML IDs and names of the elements that we will send in the form data. And then I'd like to call your attention for this. This is the Ajax submit. We are doing the post, sending the form data content as well as that Ajax element. And if you see, what we are receiving is a JavaScript reply from the server that contains the message that we are expecting. So let me, out of the top of my head, I think it was submitted. Yeah, so this is the feedback message that the server replies saying that the case was successfully submitted. And the reply also includes here a redirect to another page, which in this case is the page to show the details of the case. But as you might recall, JMeter will not execute JavaScript, meaning that we will not be able to follow this redirect. So let me just show you quickly here in the bringing in the cases application. So just to that you can verify that the cases are actually being created through the execution of this test. So this is our cases application. We have currently 6 new cases, but if we run again the script, you shall see that a new case was created due to this test run. So we will have now 7 cases. So let's increase the heat here on this test and inject some load in the system, so to see how it behaves. Imagine this would be a round of testing to decide if the application was fit enough to ship to production. So let's say I want, again, 10 users. I want a reduced ramp-up period, so in 2 seconds I will have my threads running. And I will do 3 iterations of this thread group, meaning that once all threads are over, the thread group will restart again, and we'll do that until the count of 3. And let's also inject here some additional elements here to proper simulate a human behavior. So first, let's say we want a single user to create not 1, but let's say 3 cases. So we inject here a loop controller, which in JMeter terminology is a logic controller. This is an element that allows you to change the logic that JMeter uses to issue the requests. This particular one will only perform a loop. So I will run this 3 times, and let me bring here to my loop also the navigate to screen, which is the request that requests the empty form. And to proper simulate the human behavior, I'll add a timer here. Let's say random timer of at most 3 seconds. And what this means is that before each of these requests, that are inside of this controller, before the request is executed, JMeter will perform a pause that will have a random value up until 3 seconds. So this will simulate the time that the user might be filling the form or navigating to another screen. So let's also, besides this, remove our test samplers, which are no longer needed. So our debug samplers and the view results listener. And let's add some more listeners here. So again, the aggregate graph with the aggregation values for each request. And let's also bring in a response time graph that will track the response time of each request during the test execution. And finally, another aspect that is also relevant is the fact that you are able to store the results of the test run by specifying here a file on your disk, and this allows you to do an offline analysis of the test run, or even use it to import the file to other analysis tools that are scattered throughout the web. So let's just create here a log file so that I can show you. And you can also display exactly what are the pieces of information that should be stored for each request that's issued by JMeter. So let's just use the default configuration for now. So let's recap. We have 10 threads with a 2-second ramp-up period in a 3-count loop. So each thread will perform 3 submissions of cases. So if we make the math, 3 times 3 times 10, we should have 90 cases by the end of the test. So let's get the engines running. And as you can see here on the top right side, these are the number of active threads that are currently running in JMeter. And you can see here in the threads, in the sample counter, the number of samplers that have been executed by JMeter. So by the end of the test, we should have, as I said, 90 cases being created. So we can also see the averages and the aggregates being computed as the test is being executed. And so far, the system is handling well the concurrent requests, so no errors. The average seems fine, and the test is over. So it took us 1 minute to run this test. We can see here in the listener the averages of each request issued by JMeter. Here in the response time graph, you will see a different kind of treatment of the data, the same data here. So you can see the evolution of response time. In fact, the login action is having an increase because of the number of concurrent users logging in. But on the other side, the login screen is decreasing the response time. So I would say that based on this, we could ship the application. So it's handling well for this specific load configuration, but from here on, you could start to increase the load, and by performing the same configurations here in the number of threads, by introducing controllers in your test flow, and you can eventually increase the load to a point where you start to identify what are the peak loads that your application can handle and where does your infrastructure stop responding to. So let me just, before finishing this, show you the output that JMeter generated. So remember that we specified here a results file. Well, whether you specify it here or here is the same, because JMeter will always store the same information, but it will render it differently according to the listener that you have selected. So let me quickly grab the file. And this is the information that JMeter collected during the test run and that you can use for further processing after the test is finished. So moving back here to our presentation. So we were able to quickly set up these two scenarios using these templates that we created, and that will gladly supply them to you to make the same. And let me just also mention that in our knowledge base there is an entry named Sizing OutSystems Platform that you can look to have some insights on the infrastructure capacity, on some metrics of the infrastructure capacity of an OutSystems deployment. And thank you very much for the attention.